As we look at chapter 13, we're going to look at building information systems, one of my favorite areas as it relates to information systems overall. Here we discuss the first two of four different types of organizational change that information systems can enable. Think about examples of each type of change within the context of an example of a business. So, for example, a pizza chain. Can you define TQM, which makes achieving quality an end in itself, and Six Sigma, which specific measure of quality, 3.4 defects per million. If you had to evaluate the two methods, which one would be better in some industries or types of businesses over the other method? Which method would be better for a restaurant chain? What about a clothing manufacturer, and why? Here we look at the third and fourth types of organizational change that information systems can enable. Think about examples of each type of change, again, within the context of an example of a business, thinking back to that pizza chain. When we think about an example of a paradigm shift, could be Schneider National, which changed its business model from being a long haul trucking and transportation firm to using its information systems to manage logistics for other companies. The most common forms of organizational change are automation and rationalization. These relatively slow moving and slow changing strategies present modest returns but little risk. Faster and more comprehensive change, such as redesign and paradigm shifts, carry high rewards but obviously offer substantial chances of failure. The graphic overall illustrates the four type of change, identifying them according to the potential return on investment as well as level of risk. What makes automation a low risk? What makes a paradigm shift or redesign a high risk? It is important to note that BPR and paradigm shifts have high failure rates. Why do you think so? Perhaps organizational change is difficult to orchestrate. This slide emphasizes business process management, a category of tools and techniques that help firms redesign business processes. The riskiness of business process redesign and the need to properly manage it in order for BPR to be effective. Can you identify the importance of each step? For example, why is it important to determine the right business process to change rather than all business processes? Some processes may not yield time or cost savings, or you could spend too much money trying to improve all processes, and some processes may already be effective. Think about an example of a business process and ask how that process could be measured. For example, how would you measure the business process of a customer ordering a meal? Or a kitchen preparing and delivering that meal? What about the business process of hiring a new employee? It is important to note that even with an effective process redesign, a majority of re-engineering projects do not achieve breakthrough gains because of inadequate change management. This slide's graphic illustrates the process of purchasing a book prior to re-engineering, including the steps if a book is not available. It emphasizes the sequential nature of the task. Besides the time taken for this process, what are other disadvantages of this traditional business process? Using internet technology makes it possible to redesign the process for purchasing a book so that it requires fewer steps and ultimately consumes fewer resources. This graphic illustrates the book purchasing process after re-engineering as an online process. The new process and technology has reduced numerous stages to 4 or 5. What are the elements that have allowed these steps to occur? Which of the 4 types of organizational change described earlier does this redesign process most closely resemble? Automation, rationalization, redesign, or paradigm shift? Excuse me. This slide gives an overview of the various types of BPM tools that firms use to redesign business processes. The text discusses the example of American National Insurance Company, which used Pegasystems BPM workflow software to streamline customer service processes across 4 business groups. BPM built rules to guide service reps through a single view of customer information across multiple systems, eliminating the need to access multiple applications when handling customer requests. This increased workload capacity of the representatives by 192%. Here we look at the activities involved in system development, or the creation of a new or improvements to an existing information system. The activities listed are usually performed in order. The first 2, systems analysis and systems design, are preparatory steps for the system. The last 4 steps translate the design of the system into actuality. It's important to emphasize that an information system is not technology for technology's sake. It is a solution to a problem or set of problems the organization perceives it is facing, including the problem of an opportunity that requires the use of information systems in order to undertake. What problems with business processes have you encountered or witnessed in your own work or educational career that could have been improved with the help of a new or improved information system? Building a system can be broken down into 6 core activities. This graphic illustrates those core activities of system building. The circular nature indicates that systems building is not a linear process that is finished once the system is built. Typically, additional changes and improvements will need to be made to the system or part of the system that will require additional analysis, design, programming, testing, conversion, and maintenance. Here we look at the first stage of systems development, systems analysis. The systems analyst first creates a roadmap of the existing organization and systems. What does the roadmap consist of? Identifying primary owners and users of data, along with existing hardware and software. What constitutes a primary owner of data? How would an analyst determine if a problem existed with existing systems? He or she would examine documents, work papers, procedures, observe system operations, and interview key users as well as managers. This slide describes the second stage of systems development, systems design. The text explains that, like houses or buildings, information systems may have many possible designs. Each design represents a unique blend of all technical and organizational components. What makes one design superior to others is the ease and efficiency with which it fulfills user requirements within a specific set of technical, organizational, financial, and time constraints. Given an identical systems analysis, what elements might be different in a system design created by two different systems designers? This slide lists the various types of specifications that must be detailed and described in a systems design. From this, it is easy to see how complex designing a system can be, and how many opportunities there are for mistakes to creep in. Problems in any one of these areas could produce a less than optimal system and losses in efficiency and productivity. Here we look at the third and fourth stages of systems development: programming and testing. Many companies today do not perform their own programming, but rather purchase software or outsource programming to a vendor. In outsourcing, who would be responsible for the testing? The vendor or the purchasing company? Would any testing be needed when software is purchased as a package? It is important to note that the importance of testing is typically underrated in systems project planning, and the risks resulting from inadequate testing are enormous. Why do you think, if system testing is performed that checks the entire system, would unit testing be important? When developing a test plan, it is imperative to include the various conditions to be tested, the requirements for each condition tested, and the expected results. Test plans require input from both end users and information system specialists. Here we look at the fifth stage of systems development: conversion. Can you describe each of the strategies listed? What would make one approach more appropriate than another? Is there any case in which a direct cutover would be the optimal strategy? This slide describes the sixth and final stage of systems development: production and maintenance, and shows that an information system is never finished. Situations in business environments always change, and systems have to change along with the business. Of course, many businesses do not want to spend the resources to change their systems as required by a changing environment. And for this reason, systems can become dysfunctional, costing the firm money fixing the problems created by an outdated system. This slide summarizes the 6 stages in system development. Here we introduce the core concepts behind a structured methodology, a prominent methodology for modeling systems. Can you identify what a process is, or give an example of a process? What does it mean to separate data from processes? This slide continues the discussion of structured methodologies, looking at the tools and techniques that it uses to model an information system. An example data flow diagram is shown on the next slide so that it may be helpful to move to that slide to discuss these diagrams. A data dictionary is needed so that system builders know exactly what data is stored and manipulated. Process specifications express the logic that is used when one piece of data is transformed by a process. The system has three processes: verify availability 1.0, enroll student 2, and confirm registration 3. The name and content of each of the data flows appear adjacent to each arrow. There is one external entity in the system, the student. There are two data stores, the student master file and the course file. Here we continue the discussion of structured methodologies, looking at the tools and techniques that it uses to model an information system. Process specifications express the logic that is used, again, when one piece of data is transformed by a process. A structure chart looks at the main function of the system, breaks it down to subfunctions, breaks subfunctions into more detailed subfunctions until the smallest level of detail is reached. Can you give an example of what the smallest level of detail might look like, for example, in a university system managing student grades and reports? This structure chart shows the highest or most abstract level of design for a payroll system, providing an overview of the entire system. This graphic shows, again, a high-level structure chart. Note that this is high level, and subfunctions exist for the functions get inputs, validate inputs, and so on. Here we introduce the second of the two main system modeling methodologies, object-oriented development. A key concept here is that of class and inheritance. This figure illustrates how classes inherit, the common features of their superclass. This graphic illustrates the concept of class and inheritance in object-oriented development. The class employee allows subclasses to be created using the template or superclass employee and use the processes and properties defined for employee. Subclasses can use properties of their superclass and also add their own properties. If a subclass intern was added to this chart, what unique properties might it have? We continue the discussion of object-oriented development, highlighting unique considerations during the system's development process. It's important to emphasize that object-oriented development can reduce the time and cost of development through reusing objects and classes from one application for other applications. This slide describes the traditional systems lifecycle method of building systems. What are the effects of unanticipated user requirements when using this type of building method? What is the role of end users in this method? What happens when users change their minds halfway through the project? And can the systems analysis be started over? The systems development life cycle partitions systems development into formal stages, each with each stage requiring completion before the next stage can begin. This slide discusses the prototyping method of systems building. Prototyping is an explicitly iterative process. The term iterative has been used several times. Do you know or can you describe what this means? In other words, iterative steps to build the system can be repeated over and over. What are the benefits of an iterative process? Note that once no more iterations are needed, the prototype becomes the finished specifications for the final application or may serve as the production version of the app. The process of developing a prototype can be broken down into 4 steps. Because a prototype can be developed quickly and inexpensively, systems builders can go through several iterations, repeating steps 3 and 4 to refine and enhance the prototype before arriving at the final operational one. This graphic illustrates the 4 steps or rectangles of prototyping. The steps that are repeated are steps 3, use the prototype, and 4, revise and enhance the prototype. Here we continue the discussion of prototyping, listing the advantages and disadvantages to using this method of building systems. This slide discusses another alternative in systems building, the use of application software packages and cloud software services. It is important to note that many functions are common to all business organizations: payroll, accounts receivable, or inventory control. Software packages or cloud software services may fulfill the need for many organizations for these types of functions. However, it is still important to perform systems analysis in order to determine your organization's requirements for a system. Here we describe outsourcing, yet another alternative in systems building. SaaS, or software as a service, and cloud computing were introduced in Chapter 5. If asked, how would you describe these types of outsourcing in your own words? We continue the discussion of outsourcing. It is important to emphasize the amount of work involved in partnering and sharing work with a vendor. It may take anywhere from 3 months to a year to fully transfer work to a vendor. Can you think of any other types of hidden costs that might be identified? If a firm spends $10 million on offshore outsourcing contracts, that company will actually spend 15.2% in extra costs, even under the best case scenario, as presented here. In the worst case scenario, where there is a dramatic drop in productivity, along with exceptionally high transition and layoff costs, a firm can expect to pay up to 57% in extra costs on top of the $10 million outlay for an offshore contract. Here we look at the best and worst case scenarios regarding hidden costs and outsourcing. The best case column shows the lowest estimates for additional costs, and the worst case reflects the highest estimates for these costs. In the additional cost column at the lower right, you can see that hidden costs increase the total cost of an offshore outsourcing project by an extra 15 to 57%. However, it is important to note that even with these extra hidden costs, many firms will benefit from offshore outsourcing if they manage the work well. Excuse me. This and the following two slides discuss application development methods that emphasize providing fast solutions needed in an increasingly digital world. What elements in RAD are similar to building methods already discussed and used in other forms of application development, such as prototyping? The slide continues the discussion of application development methods that emphasize providing fast solutions. And here we continue with low code development and no code development. The fastest growing business platform is the mobile tablet and smartphone platform. Rebuilding old applications for delivery on the new platform is an expensive challenge for many businesses. All the large enterprise software firms, for example, Oracle, IBM, and SAP, have adapted their legacy software to the mobile platform for the most part. All new application development is aimed at multi-platform delivery on the desktop, tablet, and smartphone.